So in this video, I'm going to discuss the GCD partition problem from today's CODEFORCES challenge. So if you have any doubt regarding this question, you can ping me up on Instagram, or even you can join my Discord server. I provide both the links in the comment section. I will pin them. So this is the number of test cases T, and this is the size of the array. Okay, let me focus it once. Okay, this is the size of the array and this is the array. So what we have to do is we have to partition this array into more than one part. Okay, that is, we have to at least partition it once, such that the sum of all the partitions, okay, the sum of all the sub arrays, the sum of all the sub arrays have the GCD as maximum. Okay, that is what it means. So like you may have an approach that you can find out the sum of the whole thing, and since we know that the answer would be of a factor of the sum, so like in this case 2 2 1 3, so if we partition this over here, so 2 plus 2 is 4 and 3 plus 1 is 4, so the GCD of this two are 4. There is no other optimal solution for this. 1 and 2, you can partition over here, the GCD of 1 and 2 is 1. For here, for this you can partition over here, and 1 4 and 5, and for this answer should be what, 3. So we can do it, make a partition over here and a partition over here. So 1 plus 2 is 3, 1 plus 1 plus 1 is 3, and this is 3, so all are 3, GCD is 3. Okay, for this also you can check it, but answer would be 1, that is, there will be no nothing. And for this, the most valid thing is partitioning over here. So the first, this numbers are 7, this numbers are 73, and this is 73, that is 21 and 21. So the GCD is 21. Okay, so this is what the question means basically. So if you have noticed one thing, we can say that the answer will be a factor of sum. Okay, will be a factor of sum. So see, 3 plus 1 is 4, 4 plus 2 is 4 plus 2 plus 2 is 8. So 4 is a factor of 8. 2 plus 1 is 3, 1 is a factor of 3. 5 plus 4 is 5 plus 4 plus 1 is 10. See, 5 is a factor of 10. So 3 plus 1 plus 1 plus 1, that is 6, 7, 8, 9. 3 is a factor of 9. So whatever this becomes, 1 is always a factor of every number, and this is 1, 2, 3, 4, 5, 6. 6 into 7, that is 42. 21 is a factor of 42. So this is very much sure that this is the answer would be a factor of that number. But we can check for all the factors of the number and check if there exists such an array or not, but that will be a tiresome process. So what we are going to do is, first of all, there will be sum from front, that is 0, and sum from back, that is also 0. Then run a loop from I is equals to 0 to I less than n, I plus plus, and sum from front plus is equal to ARR of I. Okay, that is, till the last element we are going to find the sum, that is basically the sum. Okay, now I will tell you why I wrote sum from front, because the optimal solution, okay, we have to know one thing, that the optimal solution occurs when you have both, we have only two parts. Okay, that is, there is only one partition. That is the most optimal way to find it. So now we run a loop from I is equals to n minus 1 to I is greater than equal to 1, I minus minus, and so sum from front will be we will be eliminating from it the position of ARR, the element of ARR at position I, and we will be adding that thing to sum back. Okay, now let's say answer was equal to 1 initially, so answer would be maximum of answer comma GCD of sum from front and sum from back. Okay, so sum from front means that if this is an array, so sum from front will be the sum of this elements, and this will be the sum of sum back elements. Okay, this is the sum back and this is the sum front, and this is I. Okay, so this is what I meant. Okay, so if you do this, you will get the maximum possible GCD and then print the answer. So this is the basic thing. Okay, so if you want, I can give you another more this GCD things. This is the thing also takes up a lot of time. So you can think of another solution. I will not explain that solution in the whole video, but I can give you a hint, that is this thing, that the answer is always a factor of sum. So if you look into this very carefully, then you can also find out some other solution. Okay, you can also find out some other solution. So that's up to you. So whatever you do. So yeah, that's it. Thank you.